Hello everyone, and welcome to part 2 of how to graph an absolute value equation, where I introduce vertical shrink, vertical stretch, and shifting. And with me is my daughter Rosalind, so she's going to help us out today in doing all this fun stuff. Now, if you remember from the last video, we learned how to graph an absolute value equation by graphing the vertex, using the slope, axis of symmetry, which is the mirror, and we do all the reflecting, and then you make a V-shaped graph. But what we're going to add to that now is shifting, vertical strength, stretch, or nothing at all. So we got to first define what all these things are. So a shift basically tells us where the vertex went from the origin coordinate 0, 0. So that means, folks, that when normal absolute value graphs start at 0, 0, and just like in football, folks, when you have your X's and your O's, so let me put in an offensive setup for those of us who know the game of football, and those of you who do not, that's okay, you're going to see what I'm talking about anyway. So let's just say, for instance, in the game of football, we have these guys right here. Now again, let's pretend that the X's are people and not pieces of a function or stuff like that. So what I mean by shifting is, have you ever watched a football game and they do something like this? Like, say, we're going to move this guy over here. And we're going to move this guy, he's going to come up, and then he's going to go over here. That movement is called a shift. And believe it or not, mathematical graphs can do the exact same thing. So let's take a look at this first one. Now I've got this graph, and again, notice that I am not at 0, 0. My vertex is way the heck over here. So again, we need to identify what the shift of this graph is. So I'm going to put that in the next slide. And notice that from the origin, here let me grab a different color. From the origin, we went to the right 5 spaces, and we went up 2. So our shift, we say we went right 5 and up 2. And that's all we have to do for identifying what a shift does. Okay, so this next one. Okay, so we have the origin right here. We're trying to tell somebody else, well, where did this thing go to? Okay, so what we're going to do, it went left 1, 2, 3 spaces and went down 2 spaces. So we're going to say that the shift went left 3 and down 2. That's it. There's your shift. All right, let's look at this next one. All right, so I have this graph. Obviously, I am not at 0, 0. So we're going to say what? Rose, what would you say this graph does? From this point right here to this one right here, where did it go? Yep, we start here and we end up here. Where did it go?
Here.
Mm-hmm. So from here we went up how many spaces?
1.
And 2, right? We went up 2 spaces. We went up 2 spaces. Therefore, we would say the shift is up 2. Pretty easy. All right, vertical shrink, vertical stretch, or none. Okay? Now, when we're talking about a shrink, we're going to take the absolute value of the slope and say it is less than 1, meaning it is a fraction. So we get like a 1/2 or a 1/3 or a 2/3, something like that. Okay? That is a shrink because we're going to make our graph kind of smaller. We say none when it is 1 because that's a perfect graph. And when it's greater than 1, 3 halves, we have 4, we have 1 1/4, stuff like that. Then we're going to say it's a stretch because it's going to pull it down. Okay? Alright, so let's take a look at this first one. We're going to ask to determine, is this a vertical shrink, a stretch, or none? Okay? So first thing you have to do is find the slope. Okay, so what we're going to do So we're going to zoom in. I got a couple points here. So let's find the slope. So I go up 1, right 1. So for those of us who know our slope is up 1 and to the right 1, that means our slope is 1 to 1, which is equal to 1. Now since my slope is 1, it's going to be none. Okay? Shrink is less than 1, stretch is greater than 1. Absolute value, of course. Absolute value. And the absolute value of A is equal to 1. So shrink is smaller than 1, stretch is bigger than 1, and none is 1. Okay, let's look at the next one. Alright, so we got a different graph. Now notice this is going in the negative direction. So the first thing I still have to do is get the slope. So I'm going to go down 1. Okay, so minus 1. I'm then going to go to the right. 1, 2, 3. Okay, so my slope
Stretch.
is negative 1/3. Now obviously we need to take the absolute value of this. Now remember folks, absolute value makes everything happy. So it makes everything positive. So it's going to be positive 1/3. Now is 1/3 less than 1, greater than 1, or is equal to 1? What do you think, Rose? Is 1/3 less than 1, greater than 1, or equal to 1?
Equal.
No, it's not equal, because equal would be the number itself. Is a fraction like 1/3 smaller than 1 or bigger than 1?
Smaller than 1.
Smaller than 1, so it's less than. Now since it's less than, it's going to be smaller than normal, so it's shrunk or shrink. Okay, alright, let's look at the next one. Alright, so we got a bigger graph here, so let's zoom in. Let's pick a couple of points. Okay, let's get the slope. So I'm going to go up 1, 2, 3, and over 2, 1, 2. So up 3 is plus 3, right 2 is plus 2. So my slope is 3/2. Let's take the absolute value, and then the absolute value of a positive number is still positive, so 3/2. Now again, we ask ourselves, is 3/2, now remember, 3/2 is really 1 1/2. So Rosalind, is 1 1/2 smaller than 1, bigger than 1, or is 1?
Bigger.
Bigger, right. So this is greater than. And since it's going to be bigger than normal, this is going to be a stretch, like a stretched out person, a tall person, right? Alright, let's look at this next one. Again, shrink, stretch, or none. But again, it's moved a little bit, but that's okay when we're determining shrink or stretch. So let's take a look at this. And I'm going to use my lightsaber pointer this time because I haven't used it yet in this video. Alright, so here we go. 1, 2, and over 1. So my slope, I went up 2 and to the right 1. So it's plus and plus. Whoops, hey. Alright, so let's shrink out. Let's go over here a little bit. So again, we said my slope is 2/1. So let's take the absolute value of that. That's still going to be just positive 2/1, which is just 2. So now let's think. Is 2 smaller than 1, bigger than 1, or is 1? What do you think, Rosa? It is bigger. So it is greater than. And since it's greater than, are we talking about a small, a large, or equal?
Large.
The large, the stretch, right. Alright, now here's where we're going to start mixing the two things together. I'm asking you to identify the shift and then tell me if it's a shrink, stretch, or not. Alright, so here we go. First thing I notice, again, is that my vertex, that's this guy right here, is not where it should be. It should be here at 0, 0, but it's not. So I have to tell everybody where this thing shifted to. Where did it go? Alright, so let's zoom in a little bit here so we can do our counting. Okay, I'm going to break out the lightsaber. Here we go. So I start here, I go 1, 2, 3, 4, 5. I went down 5. 1, 2, 3, 4. So I went, oh, I should put that down here, huh? Oh, hold on. Let me get my eraser. Boom. Hey, go away. There we go. All right, so again, we went down 5. And then I went to the right 4. That's my shift. That's where this went, right? All right, now we have to figure out, is this a shrink, a stretch, or none? So let's zoom in here. Let's do our count for our slope. Okay. Okay, let me get rid of this garbage. Huh? Hey, go away. Nope, I don't need that. Hold on a second, everybody. There we go. All right, so here we go. Let's get out the lightsaber. All right, so I went up 1 to the right 2. So let's remember that. We went up 1. Hey. Well, anyway, we'll go back and fix that. We went up 1 to the right 2. So my slope is 1/2. Let's take the absolute value. So positive 1/2 is still 1/2. So to do this, we're comparing it to 1. So Rosalind, is 1/2 smaller than 1, bigger than 1, or is equal to 1?
It's smaller than 1.
It's smaller than 1, so it's less than. So which one of these things represents small? A shrink. A shrink. Very good. And let me fix this. We went down 5 to the right 4. And there we go. There's that one. Okay? Let's do another one. Now again, if you're starting to get good at this, why don't you pause the video for a second so you can figure it out. For those of us who'd like to have one more solid example, Rosalind and I will work this one with you. All right, so here we go. First thing I need to do is identify, hey, forgot to turn the pen on.
Dad, this is different, putting it together.
Exactly. We're putting the two little things that we were learning together into one. Yep. So here we go. All right, now notice again, I'm not where I'm supposed to be. I'm supposed to be here, but I'm all the way up here. So we need to identify, we need to tell people where I went, okay? Because if I don't tell my wife where I go, she gets mad. So again, we don't want my wife mad at us. Okay, those of you married people, you'll know what I'm talking about. Those of you who are not, you'll know soon enough. All right, so here we go. So I go up 1, 2, 3, 4, 5. So I went up 5. So let's know up 5. Okay, and then from there we're gonna go to the left. 1, 2, 3. So left 3. Okay, so when I'm pulling this all together, let's zoom out and let's go to our line here. That movement that we just described is the line we're talking about. So we went up 5 and to the left 3. Okay, pretty easy, right? All right, now we have to figure if this is a shrink, a stretch, or none. So let's zoom back in. Okay, and let me get rid of some of this garbage right here. Okay. Well, before I do that, let's make sure I don't erase everything that we just did so we don't have to do it again. Oh, perfect. There we go. All right, so let's zoom back in. Now again, we need to get the slope. So I go down 1, right 1. So again, those of us noting slope, folks, those of us who remember, we went down 1 and to the right 1. Now remember, going down in slope, it means it's negative, so negative 1 to 1. So again, before you start thinking, oh, that's easy, that's a shrink because it's less than 1, don't forget, we have to do the absolute value of that. So the absolute value of negative 1, everyone, if we make it happy, it's going to become positive 1 to 1. It's going to be a happy 1. So again, Rosalind, there's my slope. 1 to 1 is 1.
None.
So is 1, very good. Is 1 less than 1, bigger than 1, or equal? Is 1 you're saying none because it's
none.
Equal. So this one would be a none. And not like your sister types of nuns. We're talking none. All right. Next one. All right. I'm going to give you a minute. I'm going to let you try this one on your own. I want you to identify the shift. Then tell me if this is a shrink, stretch, or none. So if you give you about 40 seconds to do that up. You know, again, I think you can handle 40 seconds. So I will come back. You can leave the video running because I'll just shut off my microphone for a second. I know you're all upset. You're not going to be able to hear my voice for a few seconds. So give it a try for a minute or so, and then we'll be back. All right, folks, we're back. All right, so first thing I need to identify is noticing that I'm not where I'm supposed to be. We're supposed to be here, but where I started is right here. So we need to take an account. Where did we go? So let's start off, okay? 1, 2, 3, 4, 5 to the right, okay? But I don't go anywhere else. So my shift in this case is just going to be to the right 5. So right, I'm going to abbreviate right RT, 5. Okay? Now, our next step, again, we're going to have to identify our shift. Not our shift, I'm sorry, shrink, stretch, or none. Okay, so let's see if I can get rid of this stuff first. Yes, I can. And let me get rid of that one too. Hey. All right, so here we go. So we'll zoom in. Let's get our slopes. All right, so looking at what we have here, I go up 2 to the right 1. So up 2 to the right 1 means my slope is 2 to 1. Okay, so let's do the absolute value of 2 over 1, which is just 2 over 1, or, whoops, not 11. That was silly of me. There we go. Or just 2. So again, we come down to it. Okay, looking at this, is 2 and 1. Is 2 less than 1, greater than 1, or is 1?
Stretch.
It is a stretch because 2 is greater than 1. So this would be a stretch. Very good. All right, let's look at another one. Now I'm really going to throw everything in the kitchen sink at you on this one. And again, I'm going to work this one with you because, again, maybe you forgot from the previous video what the vertex is, what the slope is, the axis of symmetry. But on your test coming up, you will be asked to do all this. So let's start off. Okay, first thing we have to do, we have to find the vertex. Now remember, folks, it's just looking at these two guys right here. Okay? Now, when I look at those two, remember I'm going to take the opposite of this guy. So it's going to be positive 4 here. And we're just going to grab this one right here, so that's going to be positive 1. So my slope is 4 to 1. Or my vertex is 4, 1. I'm sorry, not my slope. Now, the next thing we do, we have to find the slope. And where is the slope again? Oh yeah, it's right here. So my slope is negative 3/4, which means I'm going to go down 4, or down 3, I'm sorry, and to the right 4. Now, axis of symmetry, remember this is my mirror line. This acts like a mirror in math. So what it does on one side, what the points do on one side, you do that on the other side as a reflection. Now remember, to find the axis of symmetry, we just say x equals 2. Now the axis of symmetry is the x coordinate of the vertex. So that's 4. All right. Now let's start off. Okay, first thing we need to do, let's graph the vertex. My vertex is 4, 1. Okay, so let's zoom in on the graph here. We're going to find the coordinate 4, 1. So I go to the right 4 and up 1, make my point. Okay, I'm going to make this pen a little bit fatter. Like so. Now, our next step, remember, again, we're going to put in our axis of symmetry, our slope point next. Slope. Now my slope was negative 3/4, so I go down 3 to the right 4. So coming back, I am going to go down 3, 1, 2, 3, over 4, 1, 2, 3, 4. Oops. And obviously I'm going to go off the grid, so I can't really do that. Keep going. So let's create our axis of symmetry. Now remember, this is a dotted line through the vertex. And it's dotted because it's technically not really there. And now we reflect those points across the axis of symmetry. Now in this case, I've only got this one right here. 1, 2, 3, 4. So 1, 2, 3, 4. So my point's going to wind up right there. So let's make it like so. Alright. Now, let's create our graph. And then here's the other one. Okay. Now remember, in the other video we would have been done. However, we've got new things to talk about here. The shift, and is this a shrink, a stretch, or neither? So again, let's talk about shift. Where did we go from the origin? So again, okay, where are you going? There we go. So again, remember, my origin's here. My vertex is now here. What did we do? Again, right. To move, we went to the right 4 and up 1. That's your shift. Now, nicely enough for us, we don't have to count because we have our slope right here. So let's take the absolute value of negative 3/4. And the absolute value of negative 3/4 is positive 3/4. So what do we think? Is 3/4 less than 1, bigger than 1, or equal to 1?
Bigger.
It's not bigger. 3/4 is smaller.
Smaller.
Yep. So is that a shrink, a stretch, or neither?
Shrink.
That is a shrink, right? Very good. All right. Let's look on. All right, again, and I will work this one with you a little bit because, again, pulling it all together here. So again, first thing we need to do, we need to find the vertex, we need to find the slope, the axis of symmetry. Okay, so let's start off. Let's zoom in on this and start with this information.
I think I found the slope.
Where's the slope, Rosalind? No. Well, let's start with the vertex. That's where these two pieces are. So we take the opposite of positive. What's the opposite of positive, Rosalind? Negative. Negative 1. And we bring in negative 4. Just as it is. Now the slope. The slope is right in front. So my slope is 2 to 1, which says I go up 2 to the right 1. Okay. My axis of symmetry, x equals, and the x coordinate of the vertex is this guy right here, so -1. Alright, so here we go. Now I guess, yes, I know a lot of us are saying, well, we can do this other stuff right now, so if you're saying that, well, let's do it. Okay. Now, knowing my vertex is -1, -4. Now, some of us might have a hard time seeing that. So let's graph that first before we do the shift. -1, -4 says I go to the left 1 and down 4. So right there. There's my vertex. So again, my shift, we went left 1, down 4. Now again, some of you are saying, well, I can do the shrink, stretch, or none right now, so let's do that, I guess. So I'll bring it down here. So we had 2 and 1. So is 2 smaller than 1, bigger than 1, or equal to 1? Yeah, it will be a stretch because it is bigger than 1. Correct. Now we have the fun task. We have to graph this. Okay, now my slope is 2 to 1. Okay, so let's graph this. So from my, hey, where are you going? So my slope says we're going to go up 2, 1, 2 over 1. 1, 2, 1. Okay. Now we put in our axis of symmetry. It's coming down here. Okay. Now we're going to reflect over the axis of symmetry. So one space, so one space. One, two, so 1, 2. All right, now let's graph this up. And there's your graph. And there's everything we needed to know. All right, this last one's a bit tricky, so I'm going to work this one with you. And then the next couple you're going to do where I'm going to sit back for a minute and let you guys work. Okay? So let's take a look at this one. So let's start off with the problem itself and all this other fun stuff. Now notice I'm missing quite a few pieces of information here. Okay? I'm missing this off the end, and I'm also missing the slope. So let's take this one step at a time, right? Now remember, on this part right here, if it's not seen, it's just plus 0. I know that looks like a 6, but that's a 0. So my slope, we're going to take the opposite of this guy, so negative 2. Bring this one in as 0, and there's my vertex. Now my slope, I can't really see, but remember, a number in front of a parenthesis is just 1 or 1 over 1. So my slope is 1 over 1, which says I go up 1 and to the right 1. My axis of symmetry, x equals negative 2. So again, some folks are saying, well, I can do my shift now. I'm going to kind of do this, show you visually first where the vertex goes, and then from there we'll come back to the shift. All right, so my vertex, negative 2, 0. So I'm going to go back 2, or to the left 2. Okay, so since that's the only movement, whoops, let's get rid of that. Since that's the only movement we did, left 2. Okay, shrink, stretch, or none. Now again, my slope is 1 to 1, which means it is 1. So since 1 is going to be equal to 1, it is none. Alright, so let's graph up this beast. Alright, so here we go. Slope's 1 to 1, so up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. My axis of symmetry comes right through here. This is one of the tough ones, yes it is. And now, let's worry about reflecting. One space, so one space.
What was that?
That's my pointer. Two spaces, so two spaces. One, two, three.
Going on upstairs.
Yeah, Mommy's just putting away laundry. And 3 spaces. Okay, so here we go. There's my graph, doing like this. And let's zoom back out because we are done with this question. So it'll look something like that. Alright, this next one I'm going to leave for you to do. So I'm going to step away for about a minute and let you work on this one. And we will be back. So again, leave the video running. I will come back in about a minute or so and get this started and help you out and go from there. No.
5 plus 5 plus 5 plus 5 plus 5 plus equals 25.
Mm-hmm. Yeah, helping Rosalind with her math homework. Well, we're helping you at the same time. Look at that, folks.
Well, it's nothing.
Yeah. All right, here we go. Let's start off. Let's start with the problem. We need to identify the vertex. Now notice there's something missing. The h value. So remember, that really says the absolute value of x plus 0. So we're going to take the opposite of the 0, which is 0, and we're going to bring down the 4, which is just 4. So there's my slope. All right, next thing we need, or my vertex, vertex. Now, next thing we're going to do, let's get our slope, which is 1/2. So it says I'm going to go up 1 and to the right 2. Let me make that look more like a T. Okay. And now for our axis of symmetry, that's the x coordinate of the vertex. So x is still 0. And I'll make that look a little better because that looks awful. 0. Alright, so now if those of you getting really good at this, you probably have already got the shift and the vertical shrink, stretch, or none done. But I'm still going to plot the vertex first so people can see it. So I'm going to plot the coordinate 0, 4. So again, I'm going to zoom in on my graph. See, 0, 4 is right here. Okay, so where did my vertex go, they say? Well, looking at what we did, we just went up 4.
I'll be right back.
Okay. Now, vertical shrink, stretch, or none. So again, we look at the slope. It is 1/2. So is 1/2 less than, greater than, or equal to 1? And it is less than, which means we're dealing with a shrink. Alright, so let's go to our graphing. Our slope is 1/2. Oops, hey, where are you going? Alright, so it says we're going to go up 1 to the right 2. Okay. Now let's put on our axis of symmetry, which is our mirror line. In this case, it's going to be the y-axis itself. And let's reflect. So again, 1, 2. So 1, 2. Okay. 1, 2, 3, 4. 1, 2, 3, 4. So right there. Alright, and 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So right there. Alright, let's graph this up. We'll go like so. Do the same thing going the other way. And let's zoom back out because we are marvelous. So there is our graph and all of our information. Alright, let's try this last one out. Again, I'm going to step away for a minute or so and let you work this one out. And then when I come back, we'll talk about this last one, and then we'll go from there. Alright folks, we're back. So let's zoom into our problem. Alright, now again, looking at this, first thing I'm going to grab is the vertex. We're going to do the opposite of this guy, -3, with this guy, -2. Okay, my slope. Now again, notice, zoom in on this. Notice I got a negative here, but nothing else. So that's just -1 to 1. So my slope in this case, -1 to 1, which says I'm going to go down 1 and to the right 1. Axis of symmetry, bless you. Axis of symmetry is the x-coordinate of the vertex. So -3. Now I'm going to be a little more quick on this one, since some of you probably have already figured this out. If you have not, that's okay. Just graph the vertex before doing the shift. But knowing my shift, if it's -3 on the x, that means I'm going to the left 3. And knowing -2 on the y just means I'm going to go down 2. Alright, so now let's worry about the shrink, stretch, or none. So again, looking at my slope, it's a negative, so remember we got to do the absolute value. So we get +1. And again, is 1 less than 1, greater than 1, or equal? We all know that's equal, so this is none. Alright, so now let's talk about graphing. Alright, let's start with our vertex. Our vertex is -3, -2. So according to my shift, I went to the left 3 and down 2. Right there. Now my slope is -1 to 1. So I'm going to go down 1, right 1. Down 1, right 1. Down 1, right 1. Let's put in our axis of symmetry. And I'm going to kind of get rid... can't now. Oops. Hey. Alright, so now let's do our reflection. 1, so 1. Whoops, that looked awful. Let's try that one again. Maybe I'll zoom in a little better. There we go. So, 1. Okay. 1, 2, so 1, 2. Okay. 1, 2, 3, 1, 2, 3. And I'm sure most of us have figured out the next one's going to be 4 over. Alright, so let's connect the dots like so. Connect the dots like so. And we zoom out because we are done. Whoop, hey. There we go. And we're all set. There's that one. So that's the end of this video. Hopefully you've learned a lot. And if not, I would recommend definitely watching it again. Make sure you've gotten everything down. So, on behalf of Rosen and myself, have fun with the math.